one and all. Myself Sreevani, working as an assistant professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in the today's lecture, we are going to learn, we are going to solve problems on displacement current density. So displacement current density in electromagnetic waves and transmission lines. So before going to discuss or solve some of the problems or sums based upon this displacement current density, so what is the mathematical equation in order to represent this displacement current density, how it is related to the electric flux density, then based upon that we'll solve some of the problems, right? So generally the displacement current density is represented with J and D stands for the displacement, and JD is equal to dou D by dou T, where D is said to be electric flux density and the relation between D and E, electric flux density and electric field density, is given by D equal to epsilon into E. So JD equal to dou D by dou T. Now here the problem is given on first one is magnetic flux density, one of the problem we'll solve, then we'll move on to the displacement current density. So in a certain conducting region, H is to be given as here H is a vector which is to be given as yz into x square plus y square into ax minus y square xz ay plus 4x square y square az ampere per meter. Generally, the magnetic field intensity H is to be measured in ampere per meter, and the H value is given as yz into x square plus y square dAx minus y square xz ay plus 4x square y square az ampere per meter. Now, determine J at 5, 2, minus 3. So, in order to find here J, see, according to Ampere's circuit law. So in order to find Ampere's circuit law, that is given by integral L H dot dl is equal to I enclosed, where I enclosed is expressed in terms of current densities, means integral S J dot ds, or in general this is the integral form of Ampere's circuit law. Now in order to find the normal value of J, we need to use point form or differential form of Maxwell's equation, which is to be derived from the Ampere's circuit law. That is given by del cross H bar equal to J. So H is given. Now from that we are going to evaluate the J value, right? So here if you observe, H is to be expressed in XYZ coordinates, means XYZ coordinates are given, means the type of a coordinate system is rectangular type coordinate system. So for that, if you are going to express that in terms of determinant form, del cross H bar equal to, see in the first row you are going to write all the unit vectors related to XYZ, means AX, AY, AZ, and in the second row we are going to write the derivative terms with respect to the partial derivative terms with respect to the XYZ, means dou by dou x, dou by dou y, and dou by dou z. And in the last row, we are going to write all the magnitudes of given H is to be considered as Hx, Hy, and Hz. Why? Because H is given as Hx, Ax, and Hy, Ay, and Hz, Az. Right? So in place of Hx, Hy, Hz, by if we substitute all the magnitudes which are given in the magnetic field intensity vector H, then you're going to get del cross H value, which is to be equal to the current density as J. Right? So upon expanding this equation, see del cross H bar equal to Ax, Ay, Az, then dou by dou x, then dou by dou y, and dou by dou z. Okay, dou by dou z. Now, in the third row, we are going to write the magnitudes of the given as yz into x square plus yz into x square plus y square, then minus next one, that is minus y square xz, minus y square xz, and AZ value or HZ value is 4x square y square. 4x square y square. Upon expanding this equation, which is equal to then ax into, so dou by dou y of 4x square y square means 4 to 0 8x square y. Then minus dou by dou z of this thing. So in order to integrate, differentiate this one, in the formula itself we'll have a negative. So then it becomes plus dou by dou z of y square xz means it becomes y square x. So if you are differentiating with respect to z, dou z by dou z value is 1, hence y square x can be treated to be a constant, hence ax into 8x square y plus y square x is the resultant one. Then minus ay into. So if you consider the first row and the second column, the debt between dou by dou x of 4x square y square minus dou by dou z of this thing, right? So dou by dou x of 4x square y square means 8x y square, then minus dou by dou z of this thing means y into x square plus y square. Then plus az into. So az means first row, if you consider first row and the third column, then the determinant between these two are to be considered as minus dou by dou x of y square xz minus y square z is the resultant one, and minus dou by dou y of this thing means yz. See, dou by, see if we simplify here, dou by dou y of yz into x square plus y square. First if you simplify this one, dou by dou y of x square yz plus y cube z, right? So if you differentiate this one with respect to y, the first term becomes minus x square z minus x square z. Then second one becomes minus y cube z means 3y square z, right? Az into, first if you consider with respect to x, it will be minus y square z, and dou by dou y of this thing means yz into x square plus y square. If you multiply this one, yz into x square plus y square, it becomes x square yz plus y square into y becomes y cube into z. If you differentiate this one, the first term becomes x square z and the next one is 3y square z. So in the formula itself, we'll have negative, hence we are writing all the terms with respect to the negative. Then which is equal to ax into 8x square y plus y square x minus ay into 8xy square minus x square y minus y cube, then plus, or if you take in between all, if you take az as minus term as common, then it becomes, see, this is y square z and 3y square z means it becomes 4y square z then plus x square z, right? So this is the value which is to be obtained for del cross h. But we are writing that when is del cross h bar is equal to j, and we need to find this j at what the point is given, that is 5 2 minus 3. So j at 5 comma 2 comma minus 3 means in place of x, y, z values, if we substitute 5, 2 and minus 3, then it becomes, which is equal to ax bar into 8 x square value is 25, 8 into 25 into y is 2, then plus y square value is 4 into x value is 5 means 4 into 5, then minus ay into 8x square, 8 into x value is 5 and y square is 4, then minus x square y 25 into y value is 2, then minus y cube means 8 minus az into 4 y square z value. So y square value is again into 4 into z is minus 3, then plus x square value is 25 into minus 3. Okay, so upon simplifying all the equation at z at 5 comma 2 comma minus 3, then we'll be getting then ax bar into something, then minus AY bar into something minus AZ bar into something values to be obtained. That value is determined at J. Okay. Then find the current passing through X. So here J value is to be obtained. Then find the current passing through X, where X is equal to minus 1 and Y and Z are the two variables. Means we are writing here, see, I enclosed is supposed to find current passing through. Hence I in terms of current densities means I is equal to integral S J dot ds, which is equal to surface integral S means we are integrating this one with respect to two variables, and those two variables are Y and Z, ranging from 0 to 2. Right? 0 to 2. Hence, integral y equal to 0 to 2, z is equal to 0 to 2, j value which we have got before substituting whatever the value we have got in place of del cross h, nothing but j, then this we need to consider in order to integrate the entire equation. So that value we are supposed to write here, and the formula for ds means all the h values are to be expressed in terms of Cartesian, means x, y, z coordinate system variables. If you express all the terms into differential, hence it will be dx, dy, dz. So here y and z, yz plane is given. Further, the formula for the ds is given by dy, dz into ax we are supposed to consider. So ax term here, the j value to be expressed in terms of ax dot dy dz into ax. Okay. So further, integral y is equal to 0 to 2, integral z is equal to 0 to 2. Now j value to be in terms of ax means ax into 8x square y plus y square x. 8x square y, 8x square y plus y square x into ax dot dy dz into ax. Okay. So now on simplifying, after integrating, ax dot ax value is 1, means dot product representation of same unit vectors result is 1, and if you substitute in place of ax and ax value as 1, or instead of considering ax, if you consider the total value which is to be expressed in terms of ax, ay, az, then multiplication between means dot product representation of the adjacent vectors will be equal to 0 and the same will be equal to 1. That's why we are writing with respect to x component, and here we have considered with respect to x component only. Right? So now after integrating this one, it becomes 8x square y means 8x square y value is to be y square by 2 and substitute limits as 0 to 2, then z is to be given as 0 to 2, then plus y square means y cube by 3, limits are 0 to 2 and x to be a constant, right, which is equal to 8x square into, in place of this one means 8 by 2 consider, and y square value is 4 minus 0 into 2 minus 0, plus y cube means 8 by 3 minus 0 by 3 into x value, which is equal to 8 by 2 is 4 and 4 into 4 becomes 16. 16 to the 32x square. Okay, 32x square plus 8 by 3 minus 0 by 3 means 8 by 3 into x value. Right? So 32 into x square. So previously from the given, see for the find the current passing through x means where x value equal to minus 1. Right? So now substitute x by minus 1 in that formula. So 32 into minus 1 whole square plus 8 by 3 into minus 1. Okay. So which is equal to 32 minus 1 minus 8 by 3. So upon simplifying this one, I should be written some finite value, and the units for this I is to be measured as in terms of amperes. Okay. So this is the way we have been calculated the current passing through this particular region. Now show that del dot B equal to 0. So H value is given. Now we are going to evaluate the equation for del dot V equal to 0. So del dot V equal to 0 means, as we know that relation between V and H means magnetic flux density and magnetic field intensity is given by V equal to mu into H. Or for a free space medium means we are writing in place of mu by mu naught. So mu naught into H bar. So mu naught value, as we know that its value is 4 pi into 10 power minus 7 into H is to be given from the given value. Right? So this is the way we are going to get value of B. Now this into B bar. See, the formula for del dot B means divergence of magnetic flux density is equal to 0. This is the thing we are going to prove now. So in order to prove this del dot B, the formula for this del dot B equal to dou Bx by dou x plus dou By by dou y plus dou Bz by dou z. Right? So Bx, By, Bz values are to be, suppose if it is multiplied with mu naught into Hx, and if it is multiplied with again mu naught into Hy, and this is given by mu naught into Hz. So mu naught into Hx is given as Bx, and mu naught into Hy is given as By, and mu naught into Hz is nothing but Bz. Then in place of Bx by By Bz by all these three values along with the free space permeability value as 4 pi into 10 power minus 7, we'll be getting the value, that is del dot V bar is equal to 0 is to be obtained. Then, so this is the way we will solve the problems on magnetic field intensity in terms of magnetic flux density along with the current densities. Okay. Now, one more problem. So next, an infinitely long filamentary wire carries a current of 2 amperes in the plus z direction. Now from the given, calculate, determine B at minus 3, 4, 7. So an infinitely long filamentary wire which carries a current of, means I value is to be given, that is 2 amperes. Now I only is given. Now we need to find the magnetic flux density as B. So is there any direct relation between B and I? Means no. So from this B, first we are going to evaluate B equal to mu into H. Now in this, first we will evaluate H value. Now for an infinite long filamentary wire which carries the current of this thing case, using the Ampere circuit law, we will find the value of H is to be, that is I by 2 pi rho into A rho. Right? So I value is given as 2 amperes, 2 by 2 pi rho into A rho. So to find this A rho by rho, which is equal to rho by modulus of rho whole square. What is that rho value is given? That B value is to be evaluated at minus 3, 4, 7. So minus 3, 4, 7 by modulus of 3, 4, minus 3, 4, 7 whole square. Right? So which is equal to minus 3, 4, 7 by root over 3 square 9 plus 4 square 16 plus 7 square is 49 whole square. Right? So 9 plus 49 plus 16 plus 9, this 15, then 24, 74. So square root gets cancelled, then it will be 74. Means A rho by rho value is to be written as minus 3 A rho or else AX plus 4 AY plus 7 AZ by then 74. Right? So now substitute A rho by rho value this thing in H. Then H is to be given by here. H is equal to I by means 2A, 2 amperes. You need to write units here. 2 by 2 pi into 74, and here it will be minus 3AX plus 4AY plus 7AZ. Right? So if you evaluate the total thing, which is to be expressed as H is equal to something into AX, then plus something into AY, then something into AZ is to be evaluated. Right? So that is the value of H. Now determine B at means H is to be obtained. Then from this we are going to evaluate B value, that is mu naught into H. As we know that mu naught is the value of a free space permeability and its value is given by 4 pi into 10 power minus 7 into H. Thus H is to be considered. Right? This is the way we have been evaluated the B at minus 3 comma 4 comma 7. Right? Next, the flux through the square loop described by 2 is less than or equal to, rho is less than or equal to 6, and 0 is less than or equal to, z is less than or equal to 4, and phi equal to 90 degrees. The flux which is passing through means the relation between magnetic flux, and the magnetic flux density is given by integral S B dot ds, where so rho phi z values are to be given, hence the components rho and phi and z are to be written, then d rho, comma rho d phi and dz are the three differential components of this cylindrical coordinate system. Right? Now substitute in place of b by. So what we have got a b here, from this h we right. See, instead of writing ax, ay, az, all the terms are given in the formula is rho phi z, and so it is a rho, a phi and az. Right? Instead of writing Cartesian coordinate system variables, we used to consider cylindrical coordinate system variables as rho phi z. Right? So here z and rho values are to be vary. So rho is 2 to 6, z is 0 to 4. So integral rho equal to 2 to 6 and z is equal to 0 to 4. Right? Z equal to 0 to 4, rho equal to 2 to 6. Now B, whatever the B value which is to be considered over there into ds. So here differential variable surface area formula is given from the two variables as rho and z, means rho z plane case, ds bar can be written as d rho dz into a phi. Right? So here also we need to consider a phi component only. Why? Because if you are considering a rho and az, then a phi dot a rho dot az values are to be zeros, and the dot product representation of sim unit vectors result of according to the given one, that is a phi dot a phi equal to 1. Okay, that's why a phi dot a phi only, means with respect to phi component magnitude only we need to consider. Then d rho dz into a phi. Okay, so after evaluating the b value and after integrating with respect to rho and z, if we substitute lower and upper limit as for rho it is 6 to 4 and for z it is 0 to 4, then flux is to be expressed. Right? So magnetic flux can be measured in Webers. Right? So this is the way we have evaluated the flux which is passed through a square loop described by the two things as 2 less than or equal to rho less than or equal to 6 and 0 less than or equal to z less than or equal to 4, where phi equal to 90 degrees. Phi is a constant plane, means phi equal to some constant value is given, means phi plane is given. If phi plane is given, means that thing we consider it as rho z plane. Right? Depending upon that, we have considered the surface area formula, then we have been evaluated magnetic flux density, then from that flux which is passing through that closed surface. Okay, so B in terms of our magnetic flux in terms of B means psi is equal to integral S B dot ds. So integration with respect to surface, if you consider, means we have to integrate that one with two different directions, where those two directions are given as rho and z. So rho z plane, if you consider, phi direction must be a constant one. Depending upon that, we have evaluated the magnetic flux which is passed through that surface. So generally this magnetic flux can be measured in Webers. Okay. So next, one more problem. So a parallel plate capacitor with plate area of 5 centimeter square and plate separation of 3 mm See, a parallel plate capacitor with plate area means S value is given, that is 5 centimeter square, means 5 into 5 centimeter into centimeter squares. Okay, so area, no, that's why 5 centimeter square is given, and the plate separation as which is represented with the D, and that value is given as 3 mm. Here it is centimeter, and now here it is millimeter, and has a voltage of V equal to 50 sine 10 cube T volts are to be applied to its plates. Calculate the displacement current assuming that epsilon equal to 2 epsilon naught. Okay, so epsilon equal to 2 epsilon naught, epsilon equal to 2 epsilon naught means, see here, um, 2 into epsilon naught value is 8.854 into 10 power minus 12 farad per meter, right? So first of all, we need to identify what is the given data from the given problem. So parallel plate capacitor with a plate area of 5 centimeter square means S value is given, that is 5 centimeter square, and plate separation of 3 mm value is given, that is D value is given 3 mm, and has a voltage of means V is equal to 50 into sine 10 cube T volts is to be applied to the parallel plates, and calculate the displacement current means we need to find JD, right? So JD equal to, that is dou D bar by dou T, right? Dou D bar by dou T, which is equal to, C, dou D bar by dou T. Then dou by dou T of D bar means epsilon into E bar. Why? Because we know that D bar is nothing but epsilon into E bar. Relation between electric flux density and electric field density is given by D bar equal to epsilon into E bar. Okay, and which is equal to this epsilon into, in general, the units for E is expressed as volts per meter, right? So this can be given by volts per meter, and the meter means it is the distance, that is V epsilon into V by D, right? So if you substitute E by this thing, then D bar can be written as epsilon into V by D, right? So if you substitute all these things in this equation, JD equal to epsilon into epsilon by D into dou V by dou T, right? So epsilon by D into dou V by dou T. And here we need to calculate the displacement current. But here we are talking about displacement current density. So the relation between current density and current displacement current is given by here. See, ID is the notation for displacement current and JD the displacement current density. As we know that JD is equal to dou D bar by dou T, and dou by dou T of epsilon into E bar. Now if we substitute epsilon units as V by D, then dou by dou T of V by D. Then D can be a constant, hence epsilon by D into dou V by dou T is the value of JD, right? So now we are going to evaluate the value of current displacement current, and in terms of current density means JD into DS, right? So this DS is replaced by S, hence JD into S. Okay. So JD, in place of JD, if we substitute epsilon S by D into dou V by dou T, okay, which is equal to. But here in the given problem, epsilon value is given as 2 into epsilon naught. 2 into epsilon naught into S by D into dou V by dou T, right? So 2 into epsilon naught means 2 into epsilon naught value as given by here. Epsilon naught is equal to, for a free space medium permittivity, that is 8.854 into 10 power minus 12, or instead of using 8.854 into 10 power minus 12, or if you're going to use epsilon naught value as 10 power minus 9 by 36 pi, sometimes it is easy to simplify. Then, so this value, if you consider epsilon naught value 8.854 into 10 power minus 12 into S surface area. That plate area is given as 5 centimeter square, means 25 into 10 power minus 4, and by D value is given as 3 mm, that is 3 into 10 power minus 3. Okay, and dou by dou T of total into dou by dou T of, means dou by dou T of the value of V is given, that is nothing but what, 50 into sine 10 cube T, 50 into sine 10 cube T. Okay, so we are differentiating this one with respect to T, means there this 50 value is to be the constant, hence which is equal to 2 into 50 into 25 into 8.854 into 10 power minus, see here it is 10 power minus 12 and this is 10 power minus 4. So it looks like a power m into a power m n, and the formula becomes a power m into a power m into a power m into a power n is equal to a power m plus n. Then minus 12 plus minus 4 becomes minus 16. Then into 10 power 3 by 3. This is the total one. Then if you are differentiating this one with respect to T, then dou by dou T of sine becomes cos 10 cube T into 10 cube. Okay, so which is equal to 2 into 50 and here 25. 2 into 25 becomes 50. 50 into 50 becomes 2500, means 25 into 100 into 8.854 into 10 power minus 16. Already 10 power 3 is there. If it is multiplied with again 10 power 3, that becomes 10 power 6 by 3 cos 10 cube T. Right? So if you completely evaluate this thing, here 10 square, 100 can be written as 10 square and it becomes 10 power 6, and 10 power 2 is 10 power 8. So 10 power minus 16 into 10 power, it becomes, means 25 into 8.854 into 10 power minus 8 by 3 cos 10 cube T. Right? So this is ID value, which is equal to, if we evaluate this total thing, then we're going to get approximate value as to be obtained as 147.4 cos 10 cube T nano amperes, where nano representation means that value is to be multiplied with 10 power minus 9 and we are representing it with nano. Okay, so 147.4 cos 10 cube T nano amperes is the value to be obtained. Right? So this is the way we have been evaluated or solved some of the problems based upon magnetic field intensity, magnetic flux density, and problems based upon displacement current density. See, once again, I'm repeating this one, very, very important, right? So, the parallel plate capacitor with a plate area is given, that is S, right? So, 5 centimeter square. And plate separation of the distance between two parallel plates is given, that it be 3 millimeters. And has a voltage of 50 sine 10 cube T volts applied to its plates. Then calculate the displacement current by assuming epsilon equal to 2 epsilon naught. Here we need to find displacement current, means notation is ID. As we know that displacement current ID in terms of its current density as JD into integral S JD dot ds. This is the general formula. So in order to evaluate this ID, we are using all the given data as V equal to 50 sine 10 cube T and epsilon equal to 2 epsilon naught. As we know that this epsilon naught is free space permittivity, then that value is given as 2 into 8.854 into 10 power minus 12. And generally this permittivity value is to be measured with respect to the farad per meter, and epsilon equal to 2 epsilon naught means this is the value which is approximately equal to this epsilon. Then JD equal to, as we know that in order to find ID equal to JD into S, then JD first we know that. So where JD is displacement current density and it is written by here dou d bar by dou t. Then if we substitute all these things, then it will be, see here, jd into ds, then jd equal to dou d bar by dou t. Now d bar means electric flux density d and electric field intensity E is given by d bar equal to epsilon into E bar, right? So dou by dou t of epsilon into E bar can be written, and if you simplify in place of this E by, means according to the units, electric field intensity E is to be measured as volts per meter, where this meter is resembles the distance between two plates, and the distance between two plates are given as with the notation called d. Hence we are replacing m by d. Hence E bar by V by d we have considered. So epsilon into dou by dou t of V by d, then d can be considered to be a constant, hence epsilon by d is a constant, dou V by dou t, and which is equal to, so substitute all in place of jd by this thing in this formula. So integral s jd dot ds. We evaluate the total thing that will be replaced by here s, hence epsilon s by d dou v by dou t. So substitute all the given data into the entire equation and dou by dou t of v. So v value is given as here 50 sine 10 cube t, and we are differentiating this one with respect to t. Hence only v only variable, and the rest of the things are treated to be constants. Hence all the values are substituted, and here 50 is also a constant, hence we can consider it as out of this differentiation, and we are differentiating this one with respect to t, means dou by dou t of sine t, hence it is cos t, and in place of t here 10 cube is there, then that can be considered as 10 cube. Now substitute all this, and if you simplify the total equation, then displacement current which is to be obtained from the given data is 147.4 cos 10 cube t into 10 power minus 9, right? So ID equal to 147.4 into cos 10 cube t into 10 power minus 9, right? So for this 10 power minus 9 amperes, generally the current is measured with respect to the amperes, and 10 power minus 9 resembles here nano amperes. Hence ID equal to 147.4 cos 10 cube t nano amperes. Okay, so this is the way we have evaluated or solved some of the problems based upon magnetic field intensity and magnetic flux density, right? So here what we have learned all the from all the problems. First, we have used here the relation between magnetic flux density B and the magnetic field intensity H as B equal to mu into H. Both can be expressed in terms of vectors, and we have used the displacement current density ID in terms of displacement current ID in terms of current density as integral s jd dot ds, and we have used the relation between d and e as d equal to epsilon into e, and we have revised the values of epsilon naught and mu naught, that is epsilon naught equal to 8.854 into 10 power minus 12 farad per meter, or some of the problems purpose, instead of using 8.854 into 10 power minus 12, we use 10 power minus 9 by 36 pi also is easy to evaluate. Then mu naught value is 4 pi into 10 power minus 7 Henry per meter is the value of mu naught, right? So this is the way we have solved some of the problems based upon magnetic field intensity and magnetic flux density, along with that displacement current and displacement current densities. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.